So I see that people are coming in.
Oh, nice.
We will wait a few minutes in order to let everybody join.
Donatella, can you read the chat?
Did you write?
No, but Anna Karing is asking if she is allowed to speak.
Here it is. No, participants are not allowed to speak. We do in this way so that we can all have a good webinar. Actually, I ask everybody to check that the microphone is muted. Okay, I think I will start. I will take 10 minutes, and in the meantime, people will have time to join before Andrea will start his presentation. So before starting, I ask everyone to mute his microphone, and then I remind you that this webinar is being recorded and then will be available online. You can write your questions in the chat, and we will answer to as many questions as possible at the end after Andrea's presentation. So thank you very much for joining us today. Many of you already know me. My name is Donatella Acquaviva. I work at Utvecklinscentrum for Vatten, a department of Campus Roslagen, a municipal company owned by Norrtälje municipality. I've been working here since 2017, first as a quality manager of the chemical laboratory, and then as project leader since 2018. And my focus areas are eutrophication, circular water economy, and aquaponics. What we do here at UCV, we work with the sustainable use of natural resources. Norrtälje is growing, is expanding, and we have to do it in harmony with our environment. Two of the main issues of Norrtälje are groundwater quality and availability, and eutrophication, which is a problem common to the whole Baltic region. Eutrophication happens when there is an excess of nutrients in the water bodies that then causes an excessive growth of algae and other aquatic plants. Then when they die and decompose, they rob oxygen from the water, and this eventually leads to the death of the water body. The main contributors of this phenomenon are nitrate fertilizers that drain from the fields, nutrients from animal wastes, and human sewage. So here at UCV, we have different projects dealing with the eutrophication. We work with wetlands restoration and constructions. We have a project about the improvement of the sewage collecting service for leisure boats. We work with the on-site wastewater system. We have indeed the service of counseling for the municipality, and we run and partake in several projects. And then, since agriculture is one of the main contributors to eutrophication, it is one of the reasons why we decided to start a project about aquaponics. So, our project, Aquaponiks, is about this circular farming method that allows a saving of water and nutrients. The project started in October 2019 and will run until next year in March. It is financed by Leader Stockholmsbygd, the Swedish Board of Agriculture, and Roslagen Sparbanksstiftelsen. With this project, we want to raise awareness about the environmental challenges of the agriculture sector, but in general of the food production sector. We want to disseminate information about aquaponics and the series of seminars that we did here at UCB, and now of webinars that we are doing are part of this activity. And we have built a small demo in our premises that you are welcome to come to visit in small groups. But why did we choose to start a project about aquaponics? Today we are called to deal with different challenges. We have an increasing world population. Agriculture has an important impact on our environment. And we have also to consider that agriculture, more than other sectors, is affected by the weather and the climate. And in particular, climate change will strongly impact agriculture, being some of the consequences of climate change, desertification, land erosions, droughts on one hand, but on the other hand, also exceptional precipitation being more and more common. Then we have also to think that Sweden is strongly dependent on food imports, especially for fish, fruit, and vegetables. And we have to think of this both in terms of CO2 emissions and in terms of food security. And also we, humans as a species, are overusing our resources. 2/3 of the world's fish stock are overfished, and intensive monoculture agriculture is leading to the depletion of soil nutrients. So these are just some of the challenges. So we are called to deal with important challenges, important issues, and we need to be creative. Every time we have a problem, however complex it is, we need to think of the essentials of the problem. If we go to the essentials, then this allows us to be creative and to find new solutions. So what do we need ultimately to grow vegetables? We need nutrients, water, oxygen, and energy. And this allows us not to be bounded to any particular method, to any growing media, or even to a particular place. And this is the philosophy behind all the soilless farming methods that are used nowadays, such as hydroponics, aquaponics, and nowadays we even talk about aeroponics. So I will go very quickly about what is aquaponics because I will let Andrea talk about this. But so in aquaponics, water and nutrients come from the culture of the fish, and then these are recirculated, and we need to supply oxygen and energy. This is just very quickly. Andrea is going to talk about this. Then finally, if you want to know more about aquaponics, here are some links that you can click on. So the Food and Agriculture Organization handbook about aquaponics. We ourselves used it when we had to design our demo. Fiskehus is a handbook made by Rifarm Linné. It's a handbook about suitable fish species for aquaponics. We did a video for kids in Swedish. You can read more about our demo and our project in this local newspaper article. And here are the link to the presentation of previous seminars that we had here. We also had a seminar with Svensk Aquaponik, but that presentation is not available for copyright reason. And then if you have any question about the project, about our activities, please contact me. And now I'm going to hand it over to our guest, Andrea Gambardella, engineer in Peckas Naturodlingar, the biggest aquaponics plant in Europe.
Thank you, Donatella. I hope everybody can hear me. I hope I didn't mess it up with the microphone.
No, so I'm going to mute my microphone, and I ask everybody to do the same.
All right, and then I will share my screen also. All right. Okay, I cannot see the chat or myself when I present, but I will go through everything that you have written in the end. But okay, so before starting, I would just like to introduce a little bit myself. Okay, my name is Andrea, and I'm a development engineer at Peckas Naturodlingar since 2018. I leave you my contacts, my email, my phone, so that in the end, I'll try to answer all the questions. But if you have any further question after the end of the presentation or the end of the webinar, or in general, if I cannot answer all the question at the end, then you just send me an email or call me. I will be on vacation until the beginning of October, so maybe it will take a while, but I promise I will answer all the questions. So we can start talking about what is aquaponics. So this is always a good start. And of course, one wants to give always the definition of aquaponics. And in this case, the most commonly used definition is that aquaponics is a combination of hydroponics and aquaculture. Personally, I don't really like this definition because I think that it only doubles the amount of questions, because if you don't know what is aquaponics, probably you don't know what is hydroponics or aquaculture either. So the definition that I give is that aquaponics is a farming technique that where plants take nutrients made available by them for them by bacteria which are fed on fish excretions. So I really like to stress that there are these three biological entities in aquaponics, which are fish, plants, and bacteria. Now, just quickly how it works. Donatella has already introduced it a little bit, and I want to stress also the fact that even if I use this specific setup to illustrate you how aquaponic works, in reality there are really a lot of different way of aquaponics, of doing aquaponics. There are a lot of different setups. This in particular is a recirculating, growing, media-based aquaponic, but it serves me only to show you how it works, because it shares the same principle with all the other setups. Basically, you will need a fish tank that hosts the fish, of course, and also that retains the water, so that the water doesn't have to be dispersed. then you will have a place that hosts this bacteria and a place that hosts the plants. Now, the place that hosts the bacteria is called the biofilter, and the place that hosts the plants is called the growing media. Now, they can be the same material, but it doesn't have to. So in this case, they are supposedly. I mean, if you use, for example, gravel, on the surface of the gravel, you can have bacteria growing, and at the same time, in the gravel, you will have the roots of the plants of the crop settling. Then, of course, you will need a pump because you will need to circulate the water in some way. And if you want instead to look at this system in a more physical way, then this is not a closed system, as sometimes somebody says, because you will always have water coming out from the system. So you will have a water outlet in the form of evapotranspiration of the crop or just normal evaporation. You have a harvest that counts as an outlet. So the water, to have an equilibrium, both the water and the harvest outlets has to be replaced in some way by a water inlet and some nutrients inlet, which in this case is the fish feed. And then, of course, you have an energy inlet, which is for a major part is the solar radiation. But if you want to be really nerdy, then it's also the energy for the pump, or if you use a greenhouse to heat up the greenhouse, etc. Now, just some pros and cons that Donatella has already introduced. I like the fact that I mean, there are more pros than cons, of course. Among the cons are the fact that this is usually to set up an aquaponics is usually a little bit more requires a little higher investment than just a normal aquaculture or just traditional farming. It's a little bit more complex because, of course, growing together fish and plants and having to always have an equilibrium between all these biological entities, it's harder than controlling just one biological entity at a time. And then it has a lack of standardization, meaning that probably if you have a problem in aquaponics, you will have very little supports from the community. I mean, of course, you will have support from the community, but maybe you will be probably one of the first encountering that problem. But within the pros instead, you have that, as Donatella said previously, you almost have no water wasted, because being a loop, the water runs into a loop, so it comes out only as the evapotranspiration and also in the harvest. But it's not wasted in a runoff like in what could be in a traditional farming way. And the same is valid for the nutrients. In traditional agriculture, fertilizers are most of the fertilizer goes away in the runoff, meaning that then it goes in the running water, which ends up in rivers, lakes, and the sea, where it causes eutrophication. But if you think about how well the nutrients can be, how efficient the nutrients can be used in aquaponics, I want to show you one fun fact, which is that, for example, if we talk about phosphorus, more than 70% of phosphorus natural reserves, which is called the phosphate rocks, is in Morocco and Western Sahara. And this is crazy because it means that phosphorus is one of the elements which is crucial in agriculture, and so it's a real crucial fertilizer. You will need it to in order to grow in whatever field you use. When you use phosphorus as a fertilizer, most of it goes in the runoff and you're going to lose it. So both phosphorus has an enormous geopolitical value, and it's wasted, and it causes then eutrophication instead when it reaches aquatic environment. This doesn't happen when you do aquaponics, because phosphorus within all the other nutrients stays in the loop, and it comes out only when it's absorbed by the plants. So indeed, one of the processes that aquaponics leads to no spill off into the environment, and it can be set up on any field. That means that you don't need to compete with other crops. You can or with forests or with other kind of natural environments. You can set it up an aquaponic also in an industrial or in an old landfill, for example. And of course, it gives you two kind of products, both the vegetables and the fish. So you have good product diversification when you do aquaponics. Now, I would like to introduce a little bit my company, Peckas Naturodlingar, with a little bit of history, which is always fun. Everything started with this man, Pekka Nigor, which is still alive. He's now 80+. He was a fish farmer, so everything started with fish more than 20 years ago. He had fish in the sea, and he realized that the way he was growing his fish was not sustainable, because the amount of biomass was too dense and concentrated, so that the nutrients could not be simply digested by the surrounding, by the sea. And this was start causing eutrophication. So he decided to move on land. And of course, he had to replace the let's say, the natural transformation of the nutrients, and the way to do for doing this was to couple his fish tanks to a crop, and this is what he did. And in 20 years he did this as a backyard project, until Hugo Wikström and Daniel Brännström took up this idea and raised some money, and in 2017 they started Peckas Naturodlingar. Now, I prepared a short video, and I know I need to take out my microphone in order to let you listen to this video. This is a video introducing our company, and was filmed in 2017. So a lot of things has changed since then, but it still served the purpose. So I will now play it.
Helt otroligt att tänka sig att för ungefär ett år sedan så då började vi gräva här. Och nu så har vi ju börjat leverera våra tomater, och vi har ett växthus som producerar fullt ut, och vi har fått igång allting, och vi har till och med startat med egen distribution. Vi har åstadkommit mycket på den här tiden, och vi har ju i princip hållit våran tidsplan, och det är helt otroligt i ett sånt här projekt. Efterfrågan är ju så pass hög så vi måste ju utöka här nu. Den här investeringen gör ju det möjligt, för då har vi mer att leverera. Samt att vi hoppas att kunna leverera på nya marknader, så att vi kan tända upp marknader till exempel i Stockholm och Göteborg innan vi bygger där. Det är mycket lättare för oss att investera här. Vi har mark, vi har alla faciliteter, vi har allting. Så det blir en kostnadseffektiv investering och ett bra sätt för oss att komma fram snabbt. Just nu säljer vi allt vi producerar, och vi får dela upp våra ordrar så att hålla våra kunder nöjda. Så att det är en bra och tydlig efterfrågan med ökande trend. Våra tomater säljs främst över ICA och Coop. Och vi skulle vilja expandera till exempel inom olika segmentet, det vill säga hotell- och restaurangbranschen. Genom att bli delägare i Peckas, så då är man ju med i den här omställningen som sker nu i samhället. Där då konsumenterna vill ha bättre produkter. Man börjar titta väldigt mycket på det här som kallas urban farming, att man odlar närmare konsumenten. Och där är ju Peckas en del i den omställningen. Så att om man vill vara med i det, så då satsar man hos oss.
Right, nice. So of course it was in Swedish, but there were English subtitles. I hope everybody, the quality of the video was good enough for everybody to understand. But otherwise, you can find this video on YouTube and also on our website, I think. Let me see. Okay. So here we have a short timeline, year after year. How it's still Peckas Naturodlingar is still a really young company since it was founded in 2017. But we have always we have never stopped building. We have we started in 2017 with the first facility, which consisted of 3,200 square meters of greenhouse and a fish farm which had 10 fish tanks of 40 cubics each. Then in 2018, we built a second greenhouse, which was slightly bigger than the first, 400 square meters. And also we started a new company, which is where I actually work, which is Peckas Solution, which doesn't sell tomatoes and rainbow trout.
Andrea, sorry, the audio went away. No.
Now?
No, okay.
Okay. All right, sorry. But I'm still sharing the, oops, this is another presentation. I'm still sharing the
Yes.
the screen. Okay, perfect.
Mm-hmm.
Sorry. So, I mean, I will say again a little bit about the timeline of our company. We have always been growing. I was saying since 2017 when we started with the first facility, which was 3,200 square meters and 10 fish tanks of 40 cubics each. Then in 2018, we built another greenhouse, which was slightly bigger than the first, 400 square meters. And in 2018, also we started another company, sister company, if you want, a spin-off, which is Peckas Solution, which doesn't sell tomatoes and rainbow trouts as Peckas Naturodlingar, but instead sells the concept. So we sell the system, and I'm working in this company also to develop a control system which is suited specifically for aquaponics, and it will be based on machine learning. I will talk a little bit about that later. In 2019, we opened the hatchery, and we started with the slaughterhouse so that we could produce the fish our own. We could process the fish our own from start to end. And in 2020, so this year, we built another greenhouse of 4,000 square meters. And we are at the moment constructing 5 more fish tanks, which are also 40 cubic. So we have 2 different kind of businesses at Peckas. We have Peckas Naturodlingar, which at the moment is the mother company, where we produce tomatoes and rainbow trouts in aquaponics. And then, as I said, we have Peckas Solutions, which is where I work, because we want more and more growers to start farming in aquaponics. And we want, of course, them to use our system. So we sell our concept, I mean, the way we do aquaponics through Peckas Solutions. And here we are also developing this control system, because there is none at the moment. There is no control system that takes care of all the parameters that you need in aquaponics. And this control system will be based on machine learning, artificial intelligence. So today, to sum up, the facility is located in Härnösand in Sweden, and it consists of 3 greenhouses for a total of a little bit more than 1 hectare. The fish farm is still only 10 tanks, but of 40 cubic meters each, but 5 more of 40 cubic meters each are under construction. We have a small hatchery, a slaughterhouse, the research and development department, a packing space. So we have our own logistic and distribution, and of course warehouse and offices. In total, we are around 30 employees. In reality, these figures are a little bit uncertain because, as I said, we have been always growing. So these numbers have never been really constant. So also the production capacity. Now this refers to what we expect to grow with our three greenhouses plus the 10 fish tanks, and that's about 500 tons of tomatoes per year and 40 tons of rainbow trouts. So we have a line of products. We have several different kinds of tomatoes. We have cherry, beef tomatoes, salad tomatoes. This that is in Swedish is called kvisttomat. I think it's a vine tomatoes in English. Then of course we have and this you will find in the shops. Then we have also rainbow trouts that we sell both fresh to grossister, to the restaurant distribution. And then we have also sometimes seasonally, let's say, we have smoked rainbow trouts. That these sometimes you can also find in the shops. And then we have two different kind of tomato marmalades and a barbecue sauce, but these are really marginal products. Our main products are tomatoes and fish, of course. Now let's talk a little bit more about the system. Now I want again to remember that there are several different kind of aquaponics setups. So now I will go in more in detail on our specific aquaponics setup. And here is a picture, which is actually the original Peckas Naturodlingar drawing. So it also has a really historical value for us. And it still describes quite well what we do, because we didn't change a lot in terms of concepts. So as you can see, this is a closed loop. It's recirculating, and it's gravel media based, meaning that we have both the biofilter and the growing media being the same material in what is called the biobed. Now, being a loop, it has no start and no end. But when I explain, I like to start explaining from the fish part. So, of course, we have a fish farm in tanks. We feed the fish, and the fish, of course, poops. This is a biological ABC. And then the water, which is enriched with these nutrients, which in the beginning are actually toxic for the fish. So you don't want these nutrients to build up, because they are in form, for example, of ammonia, which is quite toxic for the fish, is led by gravity to this big boxes full of gravel, and where the plants are actually. And there are a family of bacteria, which are called the Nitrosomonas and Nitrobacter, which are essential in aquaponics, because they turn they oxidize the ammonia, and they turn it into nitrates in a process called nitrification. And nitrates, apart from being much less toxic for the fish, of course, to a certain extent, I mean, everything is toxic in a huge dose, but nitrates are really well tolerated by the fish. But also nitrates are one form which is bioavailable by the plant for the plants, meaning that this is a form in which the plants can suck up the nitrogen. And of course, it's not only about the nitrogen. It's also a lot of the different chemicals. It's a cocktail of different nutrients. But it's really important to talk about the nitrogen first, because it's probably one of the most important nutrients, and second, because this is really the cycle that it's the most important elemental cycle, let's say, of aquaponics, where you have the fish, the bacteria, and the plants working in synergy. Well, then after the water has passed through the biobeds, so the ammonia has been turned into nitrates, the nitrates has been taken from the plants, the water flows back, always by gravity, into
well where it's accumulated, and that also works as a buffer. And from here, a pump pumps it up back to the fish tanks where everything starts over. Now, so once again, you see here in this short explanation how the fish, the plants, and the bacteria works in synergy with each other. But these are not actually the only biological entities of aquaponics. Aquaponics is actually a big ecosystem where you also have pests, for example, and you will have to fight these pests if you want to scale up to commercial aquaponic. And we fight these now. Here on the left, I show some white flies and spider mites, which are some pests, and on the right side instead there are some methods that we use to fight those, some pest control, basically to fight the pest. And they are some insects. They are natural antagonists that you can purchase from a company, both in a form of living insects or in a form of eggs that then they are glued on these little tags that you just hang in the greenhouse. Then of course the eggs hatches and go fighting and the insects go fighting your pests. And another way of dealing with these pests is having this yellow sticky stripes, which you use both, of course, to capture some of them, but mostly you use to have a control of what kind of insects are living in your greenhouse, because there are literally tons of different species of insects. Most of them are harmless, but some of them are not, and you want to keep their population under control. So I will say many times today that in aquaponics, what you really want all the time is equilibrium of all the biological entities. But well, this is the exception. You really don't want to have an equilibrium here. You drive actually the equilibrium towards the insects that are actually beneficial for your crop, and you do this by purchasing new and continuously new biologicals. It's actually a really serious business. You can see here, this is not a COVID-19 measure. It's our measure when we do exhibition to protect our crop from external intrusion of these insects. So we dress up the visitors like this. We have both the shoes, the vest here, and the net for the hair, and then you will have to sanitize your hands, of course. Now this is this probably sounds less tragic now after the pandemic, but in the beginning everybody was really hype of this when we had the exhibition. But again, there are also other kind of biological entities. In this case, now I'm talking about the pollinators. And tomatoes tomatoes is a plant that actually pollinates itself, just maybe with wind or vibration. But if you use the right pollinators, you can increase your harvest almost of 50%. And we use bumblebees to pollinate our crops. They are the perfect pollinators because they are like small brushes, small flying brushes. You can also pollinate by hand. They do it sometimes with brushes. They do it in China, for example, where the labor cost is very low. And this, of course, is not. You cannot do that. Simply doesn't pay back the results in Sweden. So we will need to have a colony of bumblebees in the greenhouse, which you can also purchase, and they work really well. But you have to they also have their own requirements that you have to balance. So, for example, the bumblebees can see the flowers only via the solar light spectrum. So you will need to have the flower which is open during when the sun is shining. if for example in Sweden or in like us in Arnosand, you will have a really short window in the winter of sunshine, and you will have to use artificial light. Well, you have to remember not to use the artificial light too early in the night, because the flower of the tomatoes opens with whatever kind of light, even with artificial light, and then closes after 10 hours, independently on what kind of light you have. So if you start too early with the artificial light, the flower will open, and then it will close also too early. So you maybe you could shorten up even more the already short window that you have for pollination in the winter, because the bumblebee maybe will then see the flowers, but it's already closed. Here is a picture of one of our greenhouse. Now the plants, this is a picture when the plants were just settled, maybe a couple of weeks after. And the greenhouse is quite modular, so you will see inside the greenhouse several rows like this. It looks almost like a railway, and this is actually a railway. This actually has a double function here in the middle of the row. These two pipes are both the radiator of the greenhouse, so it's the heating system, and it is actually the track where we move our machine inside along these roads. Then you will see also there are other pipes also being the heating system in between the plants. Then there is one running all around the greenhouse. And these boxes, these white boxes that you see where the plants are the biobeds. And here is a closer look to them where we still hadn't planted. So you see it's filled with the same gravel you would use on ice not to slipper. And there is a pipe going on top, which leads the water from the fish farm. And then you have the water drips into this gravel, where the bacteria, this Nitrosomonas and Nitrobacter, leaves and turns the ammonium that comes from the fish excretion into nitrates, which is the form that the plants can take. And you can see that our construction in the beginning was quite homemade, even if this is an industrial aquaponics. This is wood and a plastic tissue in order to tighten it up. But now we actually have developed our own design, which looks much better, and it's more industrial if you want, both for logistic. You can put these one into each other, and then it enhance the contact between the water and the gravel, so that you have an increase also of the nitrification, and it's done also so that the root system can develop in a certain way. So this is actually our if you want, our intellectual or our know-how that we sell with Peckas solution. And it also, to me, also looks much better actually. Now the crop, of course. Now I think you understood that we grow tomatoes, different kind of tomatoes, but only tomatoes. We also have some cucumbers actually, but that's only, we don't sell it. That's the R&D department. And we start the crop from we start the cycle from small plants. We purchase them from Finland actually. They come when they are at their first blooming, and we do that because it's a particular strain of tomatoes that we use. So we are not, you will not get the same results if you would use the seeds from previous plants. I don't really know the reason for this, but it is like this. So this is why we start only from plants. And the plants last up to 10 months. In reality, the plants can grow much older. But what happens is 10 months is more or less the time after which the plants stop producing to a desirable amount, let's say. And here you can see from the picture, you can see again this rails, which is also our heating system, a worker which is working on one of this elevator machine, and the plants which are hanging from the top. And here we have a better picture of it actually, because there is some work that you always have to do in the greenhouse. You will have to pruning, so take away the leaves sometimes, because you want the plants not to grow too vegetative, and also you need to expose the fruits to the light so that they can ripen faster. You will have, of course, to set the biologicals. You will have, since the plant is always growing but is hanging from the top, you will have to let down the rope which they are hanging from, little by little, and you do that by working on these elevators. But fortunately, since the cycle of the tomato ripening starts from the top as a flower and ends up on the bottom, you don't need any elevator to pick the tomatoes. So you can do this even if you have disabilities. I mean, you don't really have to. It's not a complicated job. The tomatoes which are ripe are normally at man height. Here it's a detail of one of the clips that we use to hang the tomato plants, which is not really important, but I think these are the small difference that makes. I mean, that you will have to take in consideration if you want to scale up to industrial scale aquaponics. Because I don't think that in your backyard aquaponics you will ever need such a thing, but in commercial aquaponics you probably will. Now, of course, it's inside the greenhouse. There is also a lot of control and technique, and this doesn't have to be like this. Of course, there are a lot of business that can be done low tech. But at the same time, it's true that when you scale up and when a process having more controls and technique and tech, I mean high tech, will help you for sure achieving your results a little bit faster probably. So in the greenhouse we have a climate control. And this is a turnkey solution, so we haven't reinvented the wheel. This is something that you purchase and it exists, and it's also quite straightforward, meaning that it has existed for a long time for traditional growers, and it takes into account the district heating, so the heating, how you heat up artificially your greenhouse. Curtains that you can use both to shadow the crop if it's too sunny, but normally curtains, especially here in Sweden, are used to control the humidity, because by the use of the curtains you regulate the condensation of the water, the air in the water, to the on the glass, on the external glass of the greenhouse. I mean, on the glass of the greenhouse, and by that you reduce the amount of water inside the air, and so you control the humidity. So you use the curtains mostly to increase or decrease the amount of air which can go on can go condensating on the glass of the greenhouse. Then of course you have hatches that you can open and close, which are also a method to control temperature and humidity. You have ventilation, which can increase. You used to have an homogeneous temperature and humidity all over the greenhouse, but you can increase and decrease in order to have more or less condensation or condensation on the wall of the greenhouse. Then you can have artificial dehumidifiers, because remember that when you use the curtains or the hatches to control the humidity, there you are losing energy, because your condensation also occurs with a temperature difference. So there you are exchanging heat towards the outside of of the greenhouse. Instead, when you use artificial dehumidifiers, even if you put energy inside in the form of electricity or heat to run the dehumidifiers, those energy stays inside the greenhouse, so you're not going to lose it. Then you have sprayers, which creates a mist, where you can. They are basically the opposite of the dehumidifiers. They humidify, or they cool down in the summer. In the summer, we spray a lot of this mist, which is just normal water inside the greenhouse, so that the humidity takes actually some of the heat which builds up in the greenhouse, which then we ventilate out through the hatches. Then you have CO2 control, because you know the plants use CO2 for the photosynthesis. So the photosynthesis works both with CO2 and with the light. When you don't have the light, you want to drive the photosynthesis process a little bit. We want to help the photosynthesis by giving more CO2, by letting more CO2 be available for the plant. So we inject a little bit of CO2 inside the greenhouse. And of course, we always have to be careful, because when there are workers in the greenhouse, high level of CO2 can lead to problems, of course. And then we have artificial illumination, because especially here in Härnösand, you will have 6 months with very very little light. And we use HPS, high pressure sodium lamps. They are a little bit less expensive as an investment, but they are quite expensive on the energy bill, because they use much more energy than LED lights. Part of this energy is then used anyway, because it stays inside the greenhouse in the forms of heat. But yet the electricity is costs much more than heat. So if you could, you would prefer to use LED lights. Although you cannot go fully LED, because they don't provide all the light spectra that the plants requires. Or there are studies about this actually, but LED are still considered a little bit the leading edge of the artificial illumination technology inside greenhouses. And we have LED in one of our greenhouses. So we installed them in the third greenhouse, so it's something really recent. I still don't have a complete complete picture on how they work, if they are how well they perform. So I will not give you any information about that. But they look good, at least. They look really pink inside the greenhouse. So here is another picture of our greenhouse, where I can show you a little bit of all these components I've been talking about. Again, there are these rails, the pipes that comes from the leads the water, the biobeds, the plants that are hanging, and then you can see here the vine has been growing a little bit longer. In the end of the cycle, this vine can be for each plant can be up to 20 meters long. The curtains you can see on the top and on the side, of course the tomato plants and the biobeds. And maybe you can see these yellow stripes, which are those pest control I was talking about. Next, we can switch now instead to the fish farm. We grow rainbow trouts, but there are a lot of different fish you can grow in aquaponics. We have rainbow trouts just because they cope quite well with tomatoes, because you always have to maintain an equilibrium. So there will be a lot of compromise that you will have to do, at least in our system, to grow both the fish and the crop, because the crop has their own requirements, which for the water, which sometimes are not the optimal for the fish, and vice versa. So you'll always have to maintain a balance, which is a compromise between what is optimal for the crop and what is optimal for the fish. We grow the fish since when they are fertilized egg. So we don't have our own spawn. We buy fertilized egg, and we hatch them in the hatchery, and then we grow the fish until they are 5 kilos. Actually, we have never grown one fish up to 5 kilos. This is something that we had decided really recently. We always grown fish up to maximum 2 kilos. That was our record so far. And we decided to switch now to 5 kilos because we have changed a little bit, because we have switched a little bit the burden on the sales rather than on production, because growing up to 5 kilos is more effective and you can grow the fish much better. But of course, it's a little bit more hard to sell a 5 kilos fish. You will have to probably have a little bit more of processing of your product. And we grow them in the tanks with a maximum density of 25 kilos per cubic. This is actually quite a low density if you consider, if you compare it to RAS or normal aquaculture densities, where they can go up to 80 kilo per cubic. And this is both because we care about animal welfare and because this is what our system can handle in terms of nutrients. So more fish than this in a tank will have you will have not enough nutrients conversion. You will have not enough nitrification, and you will end up building up nutrients inside the tank. Actually, we have never had 25 kilos per cubic in all the tanks at the same time. So this is a maximum for a tank. But then, of course, you will have, while the fish is growing, you will have some tanks where you have less and some tanks where you are closer to 25 kilos per cubic. You feed the fish 1% on average in the biomass, meaning that if you have 1 ton of fish in a tank, that day you will feed approximately 10 kilo of fish feed. We use pellets from skretting. Now this varies quite a lot actually from according to the size, the age of the fish, according to their appetite, their stress factors, the capacity of the greenhouse, nitrification, and so on. So every day we actually have a routine where we we measure the ammonia levels, the temperatures, pH. We measure a lot of things, and then we decide how much fish feed you should give that day to the fish. And but in general, as a rule of thumb, you can say that approximately over the entire lifespan of the fish, you will feed them more or less 1% in weight every day. And the conversion also, of course, the conversion varies between all over the lifespan of the fish. But you can say the conversion fish feed to product to fish is approximately 1-to-1, meaning that if you give 1 kilo of fish feed, that will be converted into 1 kilo of fish meat. And at the same time, we have more some rough data about the conversion of fish feed to tomatoes, and that's approximately 1-to-10 instead. And remember always that this, in order to these numbers, these figures, in order to add up in the end, you need to remember that the fish feed is these pellets are completely dry, while tomatoes and fish as well are mostly water. So that's how you can convert 1 kilo of fish feed into 1 kilo of fish, and then 10 kilos of tomatoes. Here is a picture of our facility during an exhibition. I don't have a lot of pictures. I didn't have a lot of pictures of the fish house, but still here you can see some columns which are used to aerate, to both oxygenate the water and to degas the water from the CO2, which is produced by the fish. You can see that they are in these large tanks, and from here the water flows through 3 settling tanks in Swedish trekammarbrunn system. There you separe the biggest particles, which is probably one of the only spill off of the aquaponics. In reality, in our system, we have also a drum filter that breaks down this particles. So in the end, we actually spill off nothing inside the environment. But before having this drum filter, we used to collect this flocculated particles inside the settling tanks and dispose them in the organic. Also in the fish farm, we have a lot of controls. As I said, we measure temperature, dissolved oxygen, then we have the automatic feeders to be calibrated, pH, electric conductivity. Every week then we take a full analysis of the water, where we also check all the ions, so iron, zinc, copper, there are a lot of them. Also the hardness of the water is important, and these solutions are also turnkey, so you can buy one of these control systems for fish farms. The problem is that there is nothing that takes into account the quality of the water, like for the fish farm control, to be used inside the greenhouse, and vice versa. There is nothing that takes into account the nutrients uptake or what happens inside the greenhouse that then has repercussion into the fish farm. And this is actually what makes the scale up of aquaponics really challenging. And this is why I think aquaponics has always been relegated to be a backyard, like a hobby or a research scale, and never could never do this, the little steps. I mean, the step to become a more standardized way of farming. And because what is challenging is that you have a system which is quite dynamic in the form both of the inlet, so the weather condition, the age of the crop, the age of the fish, the fact that you will have to replant sometimes, the fact that you will have to slaughter the fish and the hatching new one. But you always have to maintain a constant production flow with a constant quality of the product. So how to perform this? I mean, in order to achieve this, you always have to have a balance between all the parameters, all the entities in aquaponics. So you will have to have a water temperature which is both good for the fish and for the tomatoes. In our case, for example, the best for rainbow trouts would be 16 degrees, but that's a little bit too cold for the tomato roots to grow. So we actually balance it around 17. And then what happens is that the water heats up too much in the greenhouse, especially during the summer. So we came up with a solution of installing a heat pump that takes out the heat from the water coming from the greenhouse, and it pushes it back in the heating system. So we recycle this heat, so that both we keep the fish in a quite cool environment, and we have and we don't lose the heat that is instead transferred then inside the water in the greenhouse. You will have to balance a nutrient concentration, because traditional greenhouses, in traditional, for example, hydroponics, you will have a nutrient concentration which is actually too high for the fish to tolerate. And you always have to remember that here is a cocktail of different nutrients, so it's not taken singularly that these nutrients are stressful for the fish. It's the entire combination of all these nutrients that could be dangerous for the fish. At the same time, though, in traditional hydroponics, for example, you have cycle of irrigation. Instead, in our system, the water circulates all the time, so that the plants have much more time where these nutrients are available for them, and this leads to a root system that grows much that extends much longer than in traditional hydroponics and allows us to grow them with lower concentration of nutrients, which are actually well tolerated by the fish. At the same time, pH is also a compromise because the fish would like higher pH than the tomatoes, so we keep the pH around 6.5. And the pH varies quite a lot during the day, so we always need to adjust both with fresh water or with small correction with, for example, with nitric acid or with potassium carbonate. We adjust the pH of the water. Salinity is also another important factor, because tomatoes can tolerate a little bit of salt. Actually stimulates the roots, and somebody says that even gives enhance the flavor, and helps to keep away some kind of pathogens or some kind of bacteria in the water. Actually, the immune system of aquaponics is the biobeds, because they're the bacteria which are responsible for the nitrification are also out competing other kind of bacteria. So that's one way of keeping infection away from your fish. But having a little bit of salt in the water also helps. Then of course you will have to deal with dissolved oxygen, dissolved carbon, ammonia levels, also the nitrification, water circulation. All these parameters you always have to maintain an equilibrium playing with these parameters, and there is the optimum of these parameters is not constant during the time. You will have a circulation flow, for example, which is better to increase after you have fed the fish, because that's where you will have a higher level of ammonia, etc. So it is almost a work of art, and at the moment this is this is Pekkas' biggest know-how, let's say. Another challenge is the fact that you cannot use antibiotics to fight whatever fish infection, because the same antibiotics which will kill the undesired bacteria will also kill the really desired bacteria living in the biobeds, which are responsible for nitrification. And on the other hand, you could not even use pesticides or chemicals in the greenhouse, because those could be harmful for the fish. So there is really no product at the moment that you can use to fix the problems with your crop or with your fish, apart for maintaining a really good balance of all the parameters that of the ecosystem. So the fact that there is a lack of specific products is actually one of the other problem that one of the other challenge that slows the scale up of aquaponics worldwide. Because one example that I always do is about the fish feed, because the industry of fish feed has developed this the feed for the fish, so that the conversion for the growth of the fish is prioritized. Sometimes the health of the fish is prioritized, but yet what the fish poops out, what is left after the fish has digested, that's actually something to minimize, or something where you will it's a waste. And but instead, so in aquaculture, you will have all what is left after the fish excretion is really poor of a lot of nutrients, which are actually will be needed for the cultivation of our tomatoes, which we sometimes have to supply artificially. So sometimes, for example, if we talk about magnesium, if we talk about calcium, we will have to add a little bit of salts. We will have to add calcium nitrates or magnesium sulfate in order to, or sometimes iron in the form of iron in the so that you will also have an equilibrium for what the plants requires. Then another problem is a lack of specialized workforce, meaning that if you will start an aquaponic business, then you will need to have a lot of different expertise in several different fields. So you will need, for example, somebody knowing a lot of biology for a botanical, for example, for the plants. Then you will need somebody knowing about the fish health. You will need somebody knowing about water chemistry, a little bit of engineering, the energy. But yet you will have nobody that really have a holistic view of all these entities. So we have always a little bit struggled on making everybody or our workers understanding all the different roles of the various entities. So somebody working with the fish also has to know what are the consequences in changing the water qualities in the greenhouse and vice versa. And then some problems are not only, I mean, there are not only problems on the production side, there are also problems on the consumer side, because you will easily recognize a lot of stamps, like, for example, if I say organic or vegan, everybody nowadays knows what does it implies, what it means. But if I say aquaponics, it's probably nobody knows. Not even the institutions sometimes know what is aquaponics. And even if they know, maybe they don't really know what it implies. What are the benefits of aquaponics? Think just, for example, that we cannot mark our product as organic, because when they decided what was organic or not, they decided that if you don't grow in soil, your product cannot be categorized as organic. So although we don't use pesticides, we don't use GMOs, we don't use antibiotics, it is almost as natural as you can get, still we are not recognized as organic from the institution. I mean, our philosophy at Peckas is quite green. You can see when I showed you the product, we don't even use plastic in our packaging. And then last but not least, what is really challenging in aquaponics for the scale up is the lack of standardization. Here I took just some pictures that came from Google Images when you write commercial aquaponics, and they look completely different. You have vertical racks, you have horizontal, I don't know, these probably are also racks. Yeah, you have small fish tanks. I mean, this is, and they look really different from what we do at Peckas, for example. And I would say that this is really typical of an early stage technology. Just think of the history of aviation. In the beginning, there is always a stage where everybody comes up with a different design, because now is also the time where all the opportunities are comes, because nobody really knows what is the optimal way of growing in aquaponics. So this now the creativity is really stimulated at this stage of aquaponics. But of course, you will encounter a lot of different solutions, and each unique solution has his own unique problems, which you will have to deal alone, basically, or nobody else will help you dealing with your own specific problems, which are related to your specific setup. And here is where actually comes my job. Here is, I want to now show you one way how we want to speed up this standardization process. And we want to do it by developing a control system which takes into account all the interdisciplinary patterns and aspect of aquaponics. So both climate control in the greenhouse, water quality, and other all these biological entities, requirements, all together in one control system. And there are several ways of doing this. You can start doing setting up a physical model if you want, but to me that looks quite complicated, and then it will be an end up to itself, because the physical model that in order to create a really general physical model, you will need to have a lot of either a lot of experience, or you will need to concentrate on your facility, and then that will stick to your facility. Or you could use artificial intelligence, in this case machine learning, and what I'm using is a technique which is called neural networks. So why is this important? This is really important because there are a lot of patterns and correlation between to achieve this balance I was talking about all the time. And the correlation are between all these parameters, and sometimes these correlation are really indirect, non-linear. And here I put always an example. For example, if you talk about the sun radiation, that influences the crop evapotranspiration, that in turn influences the nutrients uptake, which influences the water quality, which influences the fish appetite, which influences the optimal feed ratio. So to a certain extent, you will have to decide the feed ratio daily according also on the sun radiation, so on the weather forecast. And there is no solution on the market that can teach you, or that gives you a way to control the feed ratio in this way. Of course, human experience, you can do this with your experience, but that will take time. That will take a lot of people growing in aquaponics with trial and error, seeing what happens when you feed this much with this weather, etc. And this will just take too long. Instead, computers, they are quite fast to understand this patterns, and neural networks are actually been proved to be quite successful in understanding the system dynamics and finding this prediction, even for both biological and physical processes. And now I will not go too much in details on how the neural network works, but you, in a simplistic way, you can see a neural network as a black box where you have an input and an output. Now, the neural network has to be trained, meaning that in the beginning, the neural network doesn't work, doesn't give you the right output. But the more, when you train the neural network, meaning that you give both inputs and the corresponding output, then the algorithm finds the pattern which is between this input and this output. And with more and more data with time, this algorithm optimizes itself and finds then to whatever input the right output, without you having to giving the output. Well, instead is the algorithm itself that provides you the output. So this way is a little bit resembles a little bit like the human understand things. The human is a little bit resembles the scientific method. You have an hypothesis, you try it, and you see the results, and you try to validate and try to find the correlation between what was your input and what is your output. And this is a little bit exactly how the neural network works. But that means that you will need to provide a neural network with a lot of data. And this is what we are doing at the moment. At the moment, we are collecting a lot of data, and we are making sure that this data is as homogeneous as possible, meaning that we will not only give data from production, we will give whatever kind of data, even data that gives a bad production, for example, or that will screw up your system. And then, of course, you will need data which is in real time. So, for example, you cannot talk about your harvest without thinking of what happened to your harvest from it since when it was a flower, for example. And this is really hard, would be really hard to do this manually. Like, you will never go inside the greenhouse and take tomato by tomato and see how big it is, how it changed in color during time. But fortunately, also using neural networks, you can we have developed some software which helps us to identify the tomatoes just by using cameras inside the greenhouse, so that we can have a stream of data all the time, and we can tell what happened to us to the tomatoes since they were small after the flower form to when they are actually ripe. Here is a small example that you can see. I take this video with my phone, and you can see that the algorithm finds the tomatoes already when they are on the vine, even when they are still unripe. And it's important to understand why I think that artificial intelligence will be the key to let other growers to start to adventure themselves into aquaponics. It's because once the system starts to understand these patterns, then through a process which is called transfer learning, which is basically the reason why if I use my algorithm here, the same algorithm will maybe not work just in the beginning, but it will take much shorter time and shorter amount of data in another place to start giving successful coordinates to the control system. So I was saying it's important to understand that the artificial intelligence can actually help the growers regardless his own setup. Meaning that yes, we will sell this control system together with our system. But if you only want to purchase the control system without our biobeds and our way of doing aquaponics, you will still have you will still get advantage of all the data that we have collected, and you yourself will be a source of data for us, so that then will increase the accuracy of our algorithm, and then will help other people also to get better results. Your system will get better in time, because you will get more and more data from both your facility and from other facilities, and Peckas will become basically the Google of aquaponics, if you want, in one sense. Here there is another example that we use the same technology also for fish. This is our how we recognize our fish. We can collect data on how they are growing, so on their size, length, also on their activities, because we can track their movements, etc. This is an example of transfer learning. Now the time is running out, but this is fortunately the last slide. This is not our facility, but you can see that the same algorithm works as well also in another environment. This was another fish farmer which was interested in our algorithms, and I processed a video that he took of his own fish, and you can see it looks quite good. So thank you for listening. I'll now stop sharing my screen and see if there are you still hear me?
Thank you. Yes. Thank you very much, Andrea, for taking us in this in the ecosystem of Peckas Naturodlingar. It was very, very interesting, very, very insightful for me, and I hope for everybody. So now, we have a couple of questions. So the first one is about the gravel. What does the gravel consist of? And yeah, maybe it looks like biochar.
No, it's not biochar. It's actually it's a natural rock. It's a granite. We really use the same gravel that, I don't know, maybe if you are in Sweden, you probably use the same this gravel on ice in the winter, not to slipper. And of course we put different size of gravels according in the biobeds in order to facilitate the water to flow and the roots to settle, but also to increase the surface as much as possible, because the more you have surface, the more you have a hosting place for the bacteria to thrive.
Yeah, also consider that there is a way to design this media bed, the media beds. So when you have basically 3 layers from up to bottom. You have a first layer that is completely dry, and its function is to protect the roots from the light. Then you have a bigger layer between 10 and 20 centimeters, where you alternate water and periods of wet, when the layer is completely wet and when it's not, so that you can have a good exchange of gas. And this is the layer where the most of the biological activity happens. And then finally, you have few centimeters of a wet layer, where another important biological reaction happens that is called mineralization. Maybe I can write it in the chat, the 2 main biological processes that happen in aquaponics. And there is another type of bacteria responsible of this. They are called the heterotrophic bacteria, but then biologists can tell you better. So then you can see better how you can design a media bed. And then the other question is, how much energy does the aquaponic consume? Does the aquaponic consume yearly? Sorry. Does this affect the price of the produce? Have you considered any energy innovations to save energy long term? For example, geothermic heat storage?
Yes. That's a really good question, actually. Yes, energy is, especially for us growing in not in the north of Sweden, but quite north, I would say. It is one of the biggest costs. I don't have, as I said, we have always been growing and adding greenhouse over greenhouses. So I don't have an exact figure on how much is the consumption per year. I can tell you that, for example, the initial facility had a use of energy that was around 2 gigabytes of heat and a little bit more 2 gigabytes of electricity per year, which is quite a lot, actually, considering that we are even buying both electricity and heat from the district heating and the local grid. So it is really expensive, and of course it affects the prices. What you can do is, yes, if you can, now we couldn't just because of our location, but if you can, of course you would rather use industrial heat, meaning maybe waste heat from another source, and you can we make sure that all our energy comes from renewable sources, because we can do that with our in our energy bill. But if you whatever different kind of energy is well accepted, heat storage can really help you sometimes, but the volume of heat that you need and the way the heat is stored sometimes doesn't really match, because if you have, for example, like us, 1 hectare of greenhouse, the heat storage will you will need to have a gigantic heat storage in order to be reasonable, to have a reasonable use, and that can be done, but it's a big investment, of course.
Yeah, and then there is a question about the fish feed that you use.
That's Skretting pellet. It's a world leader company of fish feed. We have used also a fish feed from Östersjön. I think in the beginning I wasn't there yet. I wasn't working at Peckas yet, but we found out that fish feed had some give us some problems. So we just switched to fish feed, which is instead much more used. And of course, you will never find a fish feed which is all the fish feed now commercially available contains a little bit of fish oil and fish mjöl. But Skretting is actually a really high percentage of vegetable proteins in their feed, so that's quite good.
Mm-hmm. And then, yeah, another a comment more than a question. So the challenge seems to be the energy required for the control system.
Oh, the control system requires very little energy. Because the control system is just a computer, it's a software, and of course you have some actuators like some motors here and there, but what is really energy intensive is how to keep the climate in the greenhouse. That's where the most of the energy goes, to heat it up in the winter and to light it up in the winter.
Then other two questions. So at the beginning, how did you identify your target customers? And then your initial investments. Then I guess Andrea will not be able to answer since it's a private company, but let's see.
Yeah, no, actually, I don't know. I could give you my guess, but I'm not really sure. The target customers were, of course, the people that are concerned about these environmental topics, and some restaurants, which because if you try our products now this is not advertising, but myself, I'm Italian and I'm really impressed of the quality of these tomatoes. They are actually really good even in the winter, and so the target is both those that takes really seriously the environmental aspects, and those that are really interested into quality, because as being a local producer also means that you can provide a product which is as really fresh, so really good, and top standards. If you compare it to tomatoes coming from Spain or from Morocco, which are taken from the vine when they're still unripe and they taste, and this will affect their taste, but of course maybe they are cheaper.
Yeah, GDO, I'm sorry, I'm not familiar to this. If you who wrote the question could please specify. But anyway, so yeah, to summarize, I'm very impressed by the whole ecosystem. How well we learned that bacteria are the real stars of the system. How you use bacteria both to clean the water, and then what you said about that they are basically the immune system of the plants, of everything. Yeah. And then, so about the cleaning system for who is not familiar with the Triakarma-Brun system. So basically, Peckas has a sedimentation tank first, where you let the biggest particle settle, and then as a biofilter, they use already the media bed, so they are not using an extra biofilter. And the activity, this biological process is run by the bacteria inside the bed, around the roots and across the gravel. And then as you said, two important things that this sector and in general the whole farming sector should consider. So two challenges that you mentioned: the lack of specialized personnel that it's being an issue in finding the right personnel, I mean, to work with this and to manage a whole ecosystem, as you said. And then the question of the labeling. This is very interesting, because you said that you need both the awareness of the consumers and then also the awareness of the authorities in order to promote more aquaponics, and to let people know that even though you're not growing vegetables in the soil, you have very healthy products.
Yes. All right. GDO means Grande Distribuzione Organizzata.
Okay.
Because Pierpaolo is from Italy. Yes,
Yeah.
our target was the GDO in this case. Yes, of course. But only locally, so inside Sweden for now. We are actually targeting aiming for the international market in form of franchising. So we want to sell Peckas concept, and then Peckas is born and it is a local producer, so something that has to be not made to big exports, let's say, of goods.
Then another question, except from fish food, what else do you add? You mentioned iron, copper, magnesium.
Yes, well, we add salts, nutrients in form of like fertilizers. We add them when we take, as I said, weekly analysis. So we see the levels of calcium, for example, and of magnesium, iron, boron, zinc, and we have our own recipe, let's say, of fertilizers that we add. Mostly, I can tell you a couple of them. Not because it's a secret, but because sometimes they are mixed together. They come in. They are used in agriculture, so they come in bags where they are mixed together, and they could be calcium nitrates, as I said. They could be a solution of metal ions, so iron, zinc, copper, magnesium, boron. Then you will sometimes we add nitric acid because to lower the pH if it's needed, and also because nitric acid adds nitrates. We add potassium carbonates to increase the pH. We add some salt, sea salt, sometimes to keep salinity. Sometimes, if you want, you can add phosphoric acid, but you have to be really careful with phosphoric acid. It's a triprotic acid, is quite strong, and you don't want, and it influences the calcium uptakes. You will have to go a little bit more in. I will have to go a little bit more in detail on water chemistry to explain you actually how do we mix all of them. It's not just that you do a little alchemy and you put it in the water. Every time it's almost a work of art, I would say.
Yeah, but so basically you're saying that you need to add nutrients, but also you need to do this pH management, basically. Yes, the two main functions.
In a rule of thumb, I would say you need to add what the fish cannot give you. So if you, for example, you will have sometimes, you will not have all the time the same amount of biomass in the system, meaning that when you have a very low amount of biomass, you will have to give some supplement to the water, which adds you the nutrients that the fish cannot give you. The same you have to do with the pH.
Mm-hmm. Yeah, and then we have a question if shouldn't be easier to separate the two growing systems.
Yes, this is actually a really good question because there are some aquaponics setup where it's separated. You have a RAS where you have your biofilter taking care of the nitrogen of the ammonia, let's say, and then this water goes to the greenhouse, and there you can readjust the water chemistry so that it's also optimal for the fish. And we have done this. When we opened the third greenhouse, which was supposed to go together with the fish farm that is actually now under construction, we have basically supplied the water, the nutrients to that greenhouse from one of our fish house, but the water was not coming back. So there we had a completely different water chemistry in that greenhouse. But we realized that the taste of the tomatoes was not the same. And that could be because the roots that develops in a different way, or it could be because the bacteria that are living in the biobeds are not stimulated in the same way, are not washed out in the same way as in the recirculating system. So what we will try to do instead in the future, it's an hybrid system where you because the crop actually requires much more water that you would need to just for the fish every day. So and this water that comes that is fresh is always lean in nutrients. It contains very little nutrients. So what you can do is that you can balance the fact that you are recirculating part of the water from the greenhouse with the fact that you are adding fresh water to the fish farm. In this way, this is a hybrid system where you always have a circulation, like a loop between the greenhouse and the fish house, yet you can have different water qualities. You can maintain different water qualities in the fish farm and in the greenhouse, with the fact that you have an asset, if you want, which is the fresh water coming in every day.
Mm-hmm. Okay, so it seems we don't have any more questions. So actually, I had a reminder that tonight Björn Olivius, our collaborator from Svenska Aquaponics, Björn, you mentioned that tonight on TV there is a program about Peckas and also your system, your aquaponic system in Berga, in Haninge. If you can write, please, in the chat the program where we can watch this service. Let's see. Otherwise, we will look for it. And so, if there are no more questions, we are running a bit out of time. Then we thank you very much, Andrea, for
thank you
for this virtual visit to Peckas. Yes, Andrea, if you can show again your email.
Yes, I'll write it in the chat.
Okay, thank you. The program is Vetenskapens Värld at 8 o'clock tonight. And fun, yes.
There we go.
So I also thank you everybody that joined us today. Yeah, there are other questions. I think you can write to Andrea directly. I hope you enjoy this event. It will be available online. And for any questions, you can contact me or Andrea. So thank you, everybody. I hope to see you here in UCB. Thank you, Andrea. Bye-bye.
Bye.